previous classes we saw a few problems on the designing of FIR filter. So today we will see some more problems on design part of FIR filter. So the question is, design a band stop FIR filter to reject the frequency from 2 to 3 radians per second using rectangular window given m is equal to 5. Also find frequency response. So they are telling us to find out hd of n as well as h of n. Then they are telling us to find out the frequency response h of omega. So if I write the standard equation, that is the desired frequency response of an band stop filter. So this will be the standard equation, and if we plot the magnitude response with respect to frequency for band stop filter, so this is the response which we are going to get, and they are telling us it should reject the frequency from 2 to 3 radians per second, where this 2 is nothing but our omega C1 and 3 is nothing but our omega C2. Okay, so we have the data as omega C1 and omega C2, and the unknown term is alpha. So in order to find out alpha, they have already given the value for m. So we all know alpha is equal to m minus 1 by 2, where the value of m is 5. So if I substitute in this equation 5 minus 1 by 2, so this is equal to 2. 5 minus 1 is 4, 4 by 2 is 2. So therefore the value of alpha is 2. So now I need to design a filter which rejects all the frequency between these frequency range. Okay. So in order to do so, the first thing which we need to do is I need to find out hd of n. So we all know the standard equation for hd of n is nothing but equal to 1 divided by 2 pi integral of minus pi to plus pi hd of omega into e power j omega n into d omega. Okay. Now I need to split this integral in such a way that so it should cover this part as well as this part, and it is rejecting from minus omega C2 to minus omega C1 as well as from plus omega C1 to plus omega C2. I need to divide this integral in that particular fashion. So if I rewrite the formula for hd of n according to the given filter, so hd of n will be equal to 1 divided by 2 pi. Okay. So we know we always write the limits from left hand side to right hand side. So I need to start like this. So the lower limit of the first integral will be from minus pi to minus omega C2. Then the second integral will be from minus omega C1 to plus omega C1, and the third integral will start from plus omega C2 to pi. So let us start writing. That is integral from minus pi to minus omega C2 hd of omega into e power j omega n into d omega plus integral from the second integral limit should be minus omega C1 to plus omega C1 hd of omega into e power j omega n into d omega plus the last integral is from plus omega C2 to pi hd of omega into e power j omega n into d omega. So we divided this integral which was ranging from minus pi to plus pi into subdivisions. Now we know in this subdivisions the value of hd of n is nothing but equal to e power minus j omega alpha. So let me substitute e power minus j omega alpha in the place of hd of omega. So if I start substituting, hd of n will be equal to 1 divided by 2 pi into integral from minus pi to minus omega C2 e power minus j omega alpha into e power j omega n into d omega plus integral from minus omega C1 to plus omega C1 e power minus j omega alpha into e power plus j omega n into d omega plus the third part, it is integral from plus omega C2 to pi e power minus j omega alpha into e power j omega n into d omega. Okay. Now, instead of writing this as separate exponential term, let us combine and write. Therefore, hd of n will be equal to 1 divided by 2 pi integral from minus pi to minus omega c to e power j omega into n minus alpha, okay, into d omega remains as it is, plus integral from minus omega c1 to plus omega c1 e power plus j omega n minus alpha into d omega plus integral from plus omega c2 to pi e power j omega n minus alpha into d omega. So, this part is done. Okay. Now, I need to consider two cases. So, for that, let us term this equation as equation star. In case 1, let us assume the value of n is not equal to alpha. In case 2, let us assume the value of n is equal to alpha, and let us check what is the value of hd of n. If we start with case 1, in case 1, let n be not equal to alpha in equation star. Okay. If it is not equal to alpha, the equation remains as it is. So, let me rewrite the equation. So, hd of n will be equal to 1 divided by 2 pi into integral from minus pi to minus omega c2 e power j omega n minus alpha into d omega plus integral from minus omega c1 to plus omega c1 e power j omega n minus alpha into d omega plus integral from plus omega c2 to pi e power j omega n minus alpha into d omega. So, now I need to integrate the exponential term. So, if we integrate the exponential term, it will be equal to 1 by 2 pi into e power j omega n minus alpha divided by j n minus alpha under the limits minus pi to minus omega c2 plus, if I integrate this term, it will be e power j omega n minus alpha divided by j into n minus alpha under the limits minus omega c1 to plus omega c1 plus, if I integrate the third term, it is e power j omega n minus alpha divided by j into n minus alpha under the limits plus omega c2 to pi. So, this is done. Now, what I can do? I can take j n minus alpha as a common factor out of all the three, and then I can start substituting the limits. Yes. So, if we do so, the equation will be 1 divided by 2 pi into j n minus alpha into, if I apply limits for this, it will be e power minus j omega c2 into n minus alpha minus e power minus j pi n minus alpha plus, coming to this, it will be e power j omega c1 into n minus alpha minus e power minus j omega c1 into n minus alpha. Okay, this is also done. Coming to the last one, plus e power j pi n minus alpha minus e power j omega c2 n minus alpha. Okay, and what we know, e power j theta minus e power minus j theta divided by 2j is nothing but equal to sin theta, or I can write e power j theta minus e power minus j theta as 2j sin theta. Now let me check for that combination. So here we have e power minus j omega c2 n minus alpha, and here we have minus e power plus j omega c2 n minus alpha. It is reverse, that is e power j theta should come first minus e power minus j theta. So since it is reverse, so let me rewrite the equation as hd of n will be equal to 1 divided by 2j into pi n minus alpha into, so it becomes minus 2j into sine, what is theta according to this? It will be omega c2 into n minus alpha. Okay, the first part is done. Now let me check for pi. So here we have pi, here we have pi. So it is minus e power minus j pi n minus alpha. Here it is plus e power j pi n minus alpha. So it is in the correct order. So I can directly write this as plus 2j sin pi n minus alpha. Okay. So now we are left out with the last part, that is this one. Okay. So even looking into this one, it is in the correct format, that is e power j theta minus e power minus j theta. So I can write it as plus 2j sin omega c1 into n minus alpha. Okay. Now what let us do is, let us take 2j as common factor. So if we take 2j as common factor, hd of n will be equal to 2j divided by 2j into pi into n minus alpha into sin pi n minus alpha plus sin omega c1 n minus alpha minus sin omega c2 n minus alpha. Okay. Now what I can do, I can cancel 2j with 2j. So what is left out? So it is nothing but sin pi n minus alpha plus sin omega c1 into n minus alpha minus sin omega c2 into n minus alpha whole divided by pi into n minus alpha. Therefore, the value of hd of n when n is not equal to alpha is nothing but this one. Now let us go for second case where n will be equal to alpha, and let us check the equation for hd of n. If I continue for case 2 where n is equal to alpha in star, so this was our equation star. So if n is equal to alpha, this entire power term tends to 0, so e power 0 tends to 1. Same thing happens here as well as here. So if I rewrite the equation, so it will be 1 by 2 pi integral from minus pi to minus omega c2 1 into d omega plus integral from minus omega c1 to plus omega c1 1 into d omega plus integral from plus omega c2 to pi 1 into d omega. Okay. Now if I integrate 1, so we are going to get 1 divided by 2 pi into omega under the limits minus pi to minus omega c2 plus omega under the limits minus omega c1 to plus omega c1 plus omega under the limits plus omega c2 to plus pi. Okay. So in the next step, let us substitute the limits and let us see what is happening. Okay. Therefore, hd of n will be equal to 1 divided by 2 pi into, if I substitute the first limits, it will be minus omega c2, minus of minus becomes plus pi, plus the second upper limit is omega c1, minus of minus becomes plus omega c1, plus pi minus omega C2. Okay, so we have 2 omega C1, 2 omega C2 and 2 pi. So if I add all those and take 2 as common factor, it will be 2 into omega C1 plus pi minus omega C2 divided by 2 pi. So I can cancel 2 and 2, which will be equal to pi plus omega C1 minus omega C2 divided by pi. So therefore, the equation for HD of n when n was not equal to alpha was this one. Now when n is equal to alpha, this is the equation, that is pi plus omega C1 minus omega C2 divided by pi when n is equal to alpha. So this is the standard derivation with respect to band stop filter. So if they won't give you the cutoff frequency and if they tell just omega C1 and omega C2, you can just stop to this step. Okay. So but here they have given us the value of omega C1 as 2 and the value of omega C2 as 3. Now let us start substituting the value of omega C1 and C2 in this equation and let us see what we are going to get. Then with the help of this equation, let us try to find out h of n. I have the standard equation. In this, let me substitute the values of omega C1 and omega C2. So if I do so, sin pi remains as it is into n minus the value of alpha, which we found out was 2. So I will substitute the values of alpha also, plus sin omega C1 value is 2 into n minus alpha minus omega sin omega C2 is 3 n minus 2 when n not equal to 2. This is entirely divided by pi n minus 2. Okay. Similarly, when it was equal to 2, the value will be pi plus 2 minus 3 divided by pi when n is equal to 2. So plus 2 minus 3 gives us minus 1. So I will directly write it as minus 1. Okay. So this is the equation for HD of n for the given filter. Now what I need to do, I need to find out h of n. So how to find out h of n with the help of this formula? We know we have a table. So the first column of the table speaks about the value of n. The second one speaks about HD of n. And the third value speaks about omega r of n. Why it is omega r? They are telling us to use rectangular window. So then we know h of n is nothing but the product of HD of n and omega r of n. So we know the value of small n ranges from 0 to m minus 1. The value of m is 5. So n should range from 0 to 4. So it is 0, 1, 2, 3 and 4. Now what they are telling us to use rectangular window. We know the formula, standard formula for rectangular window is omega r of n, which will be equal to 1 over the range 0 to m minus 1, and it will be 0 in rest of the cases. Okay. So for all values of n, that is from 0 to 4, the value of omega r will be equal to 1. Okay. So what I did, I have substituted the values for n in this particular equation and I have found out HD of 0, HD of 1, HD of 2, HD of 3 and HD of 4. Now in order to find out h of n, it is nothing but the multiplication of these two elements. So if I multiply any element with 1, we get the same element. So let me write all the elements directly. 0.2445 and the third one is 0.6816, fourth one is 0.2445 and the last one is 0.0759. Now the value of m which they have given is odd, and looking into h of n is symmetric, and we got the condition that is m is odd and h of n is symmetric. Under this condition, we know the formula for frequency response, which is equal to, that is h of omega will be equal to e power minus j alpha n into h of m minus 1 by 2 plus 2 into summation n ranging from 0 to m minus 3 by 2 into h of n into cos omega m minus 1 by 2 c. Okay. Now we know the value of alpha, we know the value of m. Let me substitute in this equation. So if we substitute, it is e power minus j 2n into h of m is 5, 5 minus 1 is 4, 4 by 2 is 2. H of 2 plus 2 summation n ranging from 0 to m is 5, 5 minus 3 is 2, 2 by 2 is 1, 1 h of n cos omega 2 minus n. Okay. Now what let us do? Let us expand the summation. So if we expand the summation, it is e power minus j So e power this will be equal to e power minus j 2 omega into h of 2 plus 2 into h of 0 into cos 2 omega plus 2 into h of 1 into cos omega. So now what I should do? I should substitute the value of h of 0, h of 1 and h of 2, which we obtained from this table in this equation to find out the frequency response. So if I substitute the values of h of 0, h of 1, h of 2 in this equation, so this is the standard equation, that is the frequency response, which we will get for the given question. Okay. So this is how we can solve or design a band stop filter, FIR filter from the given data. The next question is, design a high pass FIR filter using Hamming window given omega c is equal to 1 radians per second and m is equal to 5. So they are telling us to design which type of filter? High pass filter. So if I draw the response of an high pass filter, so it looks like this. So this is omega, this will be magnitude of h of omega. So if omega c is the cutoff frequency, it should pass the frequency from omega c to pi. So if I take the mirror image of this, minus omega c to pi. So it should pass the frequencies from plus omega c to pi. So that is nothing but a high pass filter, and the value of omega c what they have given is 1 and the value of m what they have given is 7. So if I find out the value of alpha, we know alpha is equal to m minus 1 divided by 2. So this is 7 minus 1 by 2, 7 minus 1 is 6, 6 by 2 is 3. Therefore, the value of alpha is equal to 3. So now what let us do is, first let us deduce the standard equation for high pass filter and then let us substitute the values of omega c and alpha. Okay. So we know the standard equation for hd of n is nothing but equal to 1 by 2 pi integral from minus pi to plus pi hd of omega into e power j omega n into d omega. Okay. So what is hd of omega? So hd of omega will be equal to e power minus j alpha omega. Okay. What is alpha? So the value of alpha is 3. So if I substitute the value of hd of omega, so the equation will be, so splitting up the integration, I can write it as 1 by 2 pi. So starting from left hand side to right hand side, it is integral from minus pi to minus omega c e power minus j omega alpha into e power j omega n into d omega plus the second integral is from omega c to pi e power minus j omega alpha into e power j omega n into d omega. So even though they have not given the desired frequency response, we know the desired frequency response for HD of, that is high pass filter, will be HD of omega, that is equal to e power minus j omega alpha for omega greater than omega c and less than pi. So keeping that thing in mind, so we can substitute what is the value for HD of omega. So now if I rewrite this equation, HD of n will be equal to 1 divided by 2 pi integral from minus pi to minus omega c e power j omega n minus alpha. So I can take e power j omega as a common factor into d omega plus integral from omega c to pi e power j omega n minus alpha into d omega. Okay, let me call this equation as equation star. Now we should start dealing with case 1 and case 2. So in case 1, let the value of n be not equal to alpha in star. Okay. If it is not equal, the same equation remains as it is. This equation remains as it is. Now what I need to do, I should integrate the exponential term. So I will integrate and write directly. So HD of n will be equal to 1 by 2 pi into integration of exponential term is e power j omega n minus alpha divided by j n minus alpha under the limit minus pi to minus omega c plus second term integrating gives us e power j omega n minus alpha divided by j into n minus alpha under the limits omega c to pi. Okay. Now I can take j n minus alpha as a common factor from both the terms and then I can start substituting the limits. So if so, the equation for HD of n will be equal to 1 by 2j into pi into n minus alpha into e power minus j omega c n minus alpha minus e power minus j pi n minus alpha plus e power j pi n minus alpha minus e power j omega c n minus alpha. Now looking into this equation, these two are one pair, this and this is one pair. So this is in the form of e power j theta minus e power minus j theta. So I can write it as it is, that is 1 divided by 2j into pi n minus alpha into, I can write it as 2j sin pi n minus alpha, correct? Coming to the second pair, so it is minus e power j theta plus e power minus j theta, but I want it in the form of e power j theta minus e power minus j theta. So for that what I will do, I will take minus as common, so I can write it as minus 2j sin omega c n minus alpha. Okay. Now I can take 2j as the common factor. So if I take 2j as common factor, so the equation for HD of n will be equal to 2j into sin pi n minus alpha minus sin omega c n minus alpha whole divided by 2j into pi n minus alpha. Okay. Hope this is clear. So now what I can do, I can cancel 2j with 2j. Therefore, HD of n will be equal to sin pi n minus alpha minus sin omega c n minus alpha divided by pi n minus alpha. So this is the equation for HD of n when the value of n is not equal to alpha. Moving to second case, I have retained equation star as it is. So in case 2, let n be equal to alpha in equation star. So if n is equal to alpha e power 0, so which tends to 1, again the power tends to 0, therefore e power 0 tends to 1. So if I rewrite the equation, hd of n will be equal to 1 by 2 pi integral from minus pi to minus omega c 1 into d omega plus integral from omega c to pi 1 into d omega. If I integrate and if I continue to simplify this, I will get 1 by 2 pi omega under the limits minus pi to minus omega c plus omega under the limits omega c to pi. Now if I substitute the limits, 1 by 2 pi summation minus omega c, minus of minus becomes plus pi minus omega c. So we have two terms of omega c and two terms of pi. So if I add those two and if I take 2 as common factor, I can rewrite this as 2 into pi minus omega c divided by 2. So I can cancel 2 and 2. Therefore the equation is pi minus omega c by pi. So this is nothing but hd of n when value of alpha is equal to n. So if I summarize hd of n from both the cases, the equation is sin pi n minus alpha minus sin omega c n minus alpha whole divided by pi into n minus alpha when n not equal to alpha. Then when n is equal to alpha, the equation is pi minus omega c divided by pi alpha. Okay, now we are ready with this equation. So what they have done, they have given us the value of omega c as 1. So let us substitute the value of omega c, and the value of alpha which we found out was equal to 3 because 7 minus 1 is 6, 6 by 2 is 3. Let us substitute that also. Therefore hd of n will be equal to sin pi n minus 3 minus sin n minus 3 divided by pi into n minus 3 when n is not equal to 3. When n is equal to 3, the equation is pi minus 1 divided by pi. Okay. So this is the first step. Now with the help of hd of n, we should find out h of n. So if I draw the table, the first column will be n, the second column is hd of n, the third column is omega h of n. Why it is omega h? They are telling us to use which window? Hanning window. So I have written it as omega h. Then omega n, which is nothing but the product of hd of n into omega h of n. Since the value of m is 7, so small n should range from 0 to 6. So let me tabulate the values of that also. 0, 1, 2, 3, 4, 5 and 6. And since it is Hamming window and the formula for Hamming window is omega h of n, which is equal to 0.54 minus 0.46 cos 2 pi n divided by m minus 1. Now what I should do, I should substitute the values of n in this formula and we should try to find out hd of n. Similarly, we should substitute the value of n in this equation and then we need to find out omega h of n. I have tabulated the values of hd of n, omega of n, and then I have multiplied these two and I have also find out h of n. Okay. So now we know the value of m, what they have given is odd, and looking into the values of h of n is symmetric. So the condition here is m is odd and h of n is symmetric. So under this condition, the formula for h of omega is equal to e power minus j alpha omega into h of m minus 1 by 2 plus 2 into summation n ranges from 0 to m minus 3 by 2 into h of n into cos omega m minus 1 by 2 minus n. Now let us substitute the values of m and alpha. We know the value of alpha is 3 and the value of m is 7. So this will be equal to e power minus j3 omega h of 7 minus 1 is 6, 6 by 2 is 3 plus 2 into summation n ranges from 0 to 7 minus 3 is 4, 4 by 2 is 2 h of n into cos omega 3 minus n. So in the next step what should I do? Expand the summation. So if I expand the summation, it is e power minus j 3 omega h of 3 plus 2 into h of 0 into cos 3 omega plus 2 into h of 1 into cos 2 omega plus 2 into h of 2 cos omega. So hope you know how to write this equation just by substituting the values of n. Now we got the equation, we know the values of h of 0, h of 1, h of 2 and h of 3. If I substitute all these values in this equation, that gives us the standard equation for h of omega for the given problem. After substituting and simplifying this equation, so this is the standard equation of h of omega for high pass filter when omega c is equal to 1 radians per second and the value of m is 7. So this is all about how to find out or how to design an FIR filter using various kinds of window. So from next class we will start with the realization of FIR filter. Thank you.